Yes, just message in the chat box if I'm audible. Yes, anyone? Today in the last class we discussed about the data forwarding technique. Okay. So data forwarding technique means to avoid the delay, right? So here, like, so here, suppose in the add instruction, okay. So R1 equal to R2 plus R3, which it is performing the addition and the result, here ALU unit is there, arithmetic logic unit. So the data is available here, right? The data is available in the clock cycle 3. So here, it is not stored in a register, but the calculation is done. So we are taking that particular value by additional hardware circuit. Okay, so the main thing is to avoid the delay. Okay, so because here the execution of this first instruction will complete at the end of the cycle 5, but here the data is available, so we are taking that particular data for the arithmetic operation. Okay, so that is called as a data the forwarding. Okay, data hazard, avoid the data hazard using avoid the data hazard, that problem, using the forwarding technique. Okay, so forwarding technique means we are taking the data here. Okay, because it is available, that's why. Okay, so in this way we can avoid the stall. Okay, so the another technique is like the compiler pipeline scheduling technique. Okay, compiler pipeline scheduling technique. Okay, compiler will automatically it will schedule. Okay, compiler pipeline scheduling technique. Pipeline scheduling technique. Pipeline scheduling technique. So the main idea is here it finds the sequence of unrelated instructions. Okay, so what it does, because in like while executing the instruction, mainly because of the dependent instruction, because of the dependency. So here you can see the second instruction R1 is dependent upon the first instruction of R1 value in the and R6 R1 R7. So here again the R1 value, it is dependent upon the first instruction, right? So that's why, because of the dependency in the instruction, dependency in the data. Okay, so delay occurs. So here like the compiler, what it does to avoid the stall. Okay, it finds the sequence of unrelated instruction. Unrelated means independent instructions. Okay, it finds the sequence of unrelated unrelated instructions. Okay, so there will be no hazard, means some independent instructions, because here in this case all are dependent. Okay, but if there is a like different registers, for example For example, here subtraction R4 comma, suppose if it is R3 comma R6, then it is an independent instruction because this instruction is separate and this instruction is separate. Okay. But here you can see there is R1 register is there, so here it is dependent. Okay, here it is dependent, and R6 comma R1 comma R7. So here also R1 is there, it is also depend upon this value, but the second instruction is there, no, it is a independent instruction, मीन्स वो कभी भी एग्जीक्यूट कर सकते हैं हम. Independent instruction, it is not depend on any value. Okay, it is not depend on any value, it is not depend on any value. Okay, so it is an independent instruction. So likewise the compiler, what it does, it finds some independent instructions. Okay, so here you can observe one thing, this is the original code. Okay, so dependent instruction must be separated from the source instruction by a distance in a clock cycle equal to the latency of the source instruction to avoid the stall. Means actually we are like separating the independent and dependent instruction. So you will understand with this example. This is the original source code. Okay, so there is a load instruction, there is an add instruction. Okay, and again there is a load instruction. So here you can observe load R2. Okay, you are loading the R2 register, you are loading the R2 register. Okay, and here in the second instruction, like you are performing R1 comma R2 comma R3, means you are adding the content of R2 and R3 storing in the R1, means R2 and R3 का वैल्यू ऐड कर रहे हो, R2 R3 दोनों का वैल्यू ऐड कर रहे हो and store the result in R1 register. So here there is a dependency there, means R2. So if we execute these instructions parallelly, then there may be delay occur because here the R2 value needs to be updated, because here in the first instruction it is loading. Okay, यहाँ load कर रहा है, loading the R2 content of this location. Then this R2 will be replaced, old value की जगह नया value आएगा. Okay, then R2 and R3 the content will be added and it will be stored in the R1, right? So here the second instruction is dependent, means some delay will occur. The same thing, and here what about the third? There is no delay here, it is independent. Load R5, the registers are different. Okay, the registers are different registers are the load. Okay, so here you can observe one thing. So this is first instruction, second instruction, third instruction. Okay, so this is the first instruction, it will execute. Second instruction, it is depend on first instruction, depend on the first instruction. I hope you are getting. Okay, because here it is taking the R2 value. Then in the third instruction, okay, in the third instruction it is not dependent. Okay, the registers are different, operation is separate. Okay, it is not dependent. So this is the original code. Okay, now the transformed code, how the compiler will do the job. This is a compiler pipeline scheduling technique, how the compiler will do. Okay, so the first instruction is same as it is here. Okay, load. Then the compiler, what it does, ये थर्ड इंस्ट्रक्शन जो था यहाँ, दिस विल बी एडेड हियर. ओके, ऊपर लेके जाता है वो. इट रीअरेंज द इंस्ट्रक्शन. It will rearrange the instruction and the second will come here. Okay, क्योंकि यहाँ एक stall आ रहा था. Okay, it was taking one clock cycle stall. Okay, there will be one clock pulse of stall. So the compiler क्या करता है वो, it will rearrange. Okay, first instruction it will be same and here this independent, this is a dependent, तो उसको क्या करता है वो थर्ड पोजीशन पे लाता है and ये जो independent है that will come in the second position. Okay, so now there is no stall. So this who will do this rearranging the instruction? Rearranging the instructions. Rearranging the instruction is done by compiler. It is done by the compiler. Compiler will reschedule. Okay, reschedule the instruction. It separates independent and dependent instructions. Okay, and also there is one more technique, so that is called as loop unrolling technique. Okay, so loop unrolling technique, how the compiler can increase the amount of instruction level parallelism by transforming loops. Because if there is a one instruction, it is okay. Okay, one instruction means it won't create any problem, but if there are the instructions in a loop, because like till the condition satisfies, it executes, like here this particular instruction for loop 1000 times. Okay, if I is equal to 1000, I is greater than 1000, it executes 1000 times, right? The same instructions will repeat. Same instruction will repeat the execution. Okay, so this original code means this loop instructions, it creates a more delay. Okay, it creates a more delay. So to overcome that, okay, so that technique is called as loop unrolling technique. Okay, loop unrolling technique. Loop unrolling technique. Okay, compiler loop unrolling technique. So what is this loop unrolling technique? So this loop unrolling is the process of reusing the loop code. Okay, just now we discussed what is loop, means the loop instructions. Okay, this particular loop is there, no? So here the loop unrolling is the process of reusing the loop code to include more than one iteration of the old code in a single pass. Okay, it uses the reusing the loop code, whatever the loop code is there in the instructions, to include more than one iteration in a single pass with new one. So the loop unrolling works by replicating the body of the loop some number of times. It will replicate number of times and scheduling the resulting code as a single block. Okay, so what it does, it will duplicate, like for example here I will show this one. Okay, so this is the like the loop instruction. See, you can see the duplicate, same load add store, load add store, duplicating. Okay, it, there are 4 copies are there are 4 copy of same load, 1 2 3 and 4. Okay, there are total 4 copies for the same loop instruction. There are 4 copies. Okay, we will discuss how you to copy this. Okay, so what it does, loop unrolling, it replicates or duplicates the body of the loop, that some number of times, and scheduling the resulting code as a single basic block, right? So replicating the loop body, replicating or the duplicating the loop, the instruction has a couple of performance advantage. Why we are duplicating? Producing the larger loop body that provides a larger block of instructions. Okay, producing larger loop body, it provides the larger block of instructions for the scheduler to work with, which gives the schedule more options when positioning the operation. Means if we execute this particular, here it is duplicated. Okay, यहाँ क्या हो जाता है, एक लूप को हमने डुप्लीकेट किया है. दिस इज 1 कॉपी, सेकेंड कॉपी, थर्ड कॉपी, 4 कॉपी, and here we are done the renaming the register. Here you can see F0 is there, F4 is there, F4, F6, F8, F8, F10, F12, F12, F14, F16. Means we'll get more instructions. Okay, if we duplicate, what happens to separate the dependent and independent instructions? Okay, dependent and independent instructions. Okay, we'll get more options, we'll get a more options if we replicate. So like earlier the loop was like only 3 instructions. Now if we replicate that, okay, so it creates a block. Like in our case there are four copies were there, so that 4 copies, it will be treated like a one block of instructions for the scheduler to work with, which gives the schedule more options when positioning the operation. More option to like separate the dependent independent instructions. Okay, so combining multiple iterations allows the variable computations to be induction variable computations to be combined. So these performance improvements are traded against the potential penalty that is caused by increased a cache miss on the larger loop body. So loop unrolling is used to minimize loop unrolling. This particular technique that is used to minimize the stalls that may be encountered inside the loops, and also get rid of overhead of the running unnecessary branch conditional. Just keep in mind why we are using this loop unrolling to minimize the stall. Loop unrolling loop unrolling means we are creating a duplicate copy so that it will form a block. Okay, so that it will form a block. So This is one copy, second copy, third copy, four copy, so that this particular it forms one block of or one set of instructions. So here it will get more options. Okay, here it will get how many 3, 3, 6, 12, 12 instructions are there. Okay, so we will get a more options. So to keep the pipeline full parallelism among the instructions, so that must be exploited by finding the sequence of unrelated instructions. The main motto behind this is to find the sequence of unrelated independent instructions. Okay, unrelated instruction that can be overlapped in the pipeline. Okay, why we are making this block number of times duplication? Because if we duplicate, then we will get more option. Okay, so that we can find the more independent instructions to avoid the delay. Okay, so to avoid the delay, a dependent instructions must be separated from the source instructions by distance in a clock cycle equal to the pipeline latency. So here for a processor, okay, the basic MIPS integer pipeline that is assumed with branches having a delay of one clock cycle, but the floating point operations that takes more time. Okay, so this is the table they are given, the instructions that producing the result. Suppose if the floating point, the floating point, single precision floating point, double precision 32 64 bit. Okay, so here the floating point arithmetic logic unit operation, if the instruction is producing the result, okay, and instruction is using the result, then it takes 3 clock cycle. It takes a 3 clock cycle. It takes a 3 clock cycle. Then floating point arithmetic logical unit, if the instruction is performing some floating point arithmetic instruction operation, okay, and like the instruction is using the result, okay, store double value, it is taking the 2 clock cycle. So here actually the normally the pipeline is assumed with the branches having a delay of 1 clock cycle, but this floating point operation that takes some extra clock cycles, like floating point arithmetic operation that takes 3 clock cycle, floating point arithmetic logic unit operation like to store the double value and all. Okay, store means suppose if we are performing the addition 3 plus 3 means it is storing some value, so it takes 2 clock cycle. Then load operation, load double, it is taking 1 clock cycle. Okay, and load double, store double value, it is taking 0 clock cycle likewise. So this is the data they are given. Okay, means how much the clock cycle it is taking, extra clock cycles, extra latency if we use the floating point operation. So before performing loop unrolling, the following assumptions are made in the pipeline. The functional units are assumed to be fully pipelined or replicated as many times as in the pipeline depth. Okay, an operation of any type that can be issued in every clock cycle, there is not a structural hazard. So here we'll discuss. So this is the code. Consider a C++ code, loop code that adds the scalar value to an array in the memory. So this particular loop, as I is equal to 1, I is less than or equal to 1000. Okay, until the condition, okay, it satisfies, it will in the loop, right? So this is the original code. Okay, this is the code, loop code. The convert the above segment of the code in a DLX assembly language format. Okay, so this particular code is there, no, C++ code that is represented in a assembly language instruction format. So this is the code for that. Okay, so here the instructions like LD operands load F0 comma this R1 register means it loads the F1. Okay, so that is F0 array element. Add instruction, add double, so it add the scalar in like F0 and okay, F0 F2 decrement store R1. Okay, so add the scalar value like F4 and F0, it will add in the F0. Okay, this is the different type of assembly language instruction. Okay, it add the scalar in F2, then store result in R1, then sub I. So here it is a decrement operation. Okay, decrement with a pointer of 8 bytes decrement pointer, and again it stored the result in R1, and this is a branch instruction. Branch R1 is not equal to 0, then it will be in a loop. Okay, means here what they have done, the above code is there, no, the C++ code, the same code is written in a assembly language format. DLX is the processor. Okay, so here with respect to this particular delay, this you know the delay time, the table. Okay, so this is the like latency that occur. Okay, like floating point operation, 3 clock cycle delay, 2 clock cycle, 1 clock cycle, 0. So based upon that, here the first step is that you have to write the code in assembly language format. That is your step 1. Step 2, arrange the code generated from step 1 by considering the stall. Okay, that is given in the table 1. So this is the stall that they are given, latency in the clock cycle. Okay, that we have to consider. So here like the first instruction is a load. Okay, load instruction, and the load instruction here in the table. Okay, here the load double, it is taking the 1 clock cycle of delay. Okay, load double, it is taking a 1 clock cycle of delay, so that is a stall. Okay, so that's why here after the load, then the floating point operation. Okay, the add double, it is taking the 2 clock cycle delay. Here it is taking 1. Floating point operation, it is taking 2 delay. Then for store double there is no delay. Here you can see store means the instruction using the result. Okay, so the load, the instruction is using the result store double, so it is taking the 0 delay. For double load, okay, floating point operation, it is taking the 1 instruction, 1 clock pulse delay, and the floating point operation, that store double means addition operation hota hai na, so that is taking the 2 clock cycle delay. So the same thing we are representing here 1 clock pulse of delay, 2 clock pulse of delay, Then for store there is no delay, there is no delay here, there is no delay, and here the branch instruction it creates a one delay. So that indicates here total it is taking the 9 clock cycle to execute the one iteration. 9 clock cycle to execute one iteration of the code. और इसमें कितने डिले है? टोटल 9 clock cycle it is taking. There is 4 stall is there, 4 delay. Okay. So next the compiler what it does, it will separate dependent and independent instructions and all. Okay. So that we discussed in the next class. Okay. So the main the thing in the pipelining that loop unrolling means it will create duplicates of the code of line, and the main thing is to avoid the like delay, to avoid the delay, so that it replicates, means it will make more options, it will make more options. So if we get more option means we will get more independent instruction. Okay, if there are more independent instruction means it is very